Well, here we are at our final topic in section 1, and this is operations with rational and irrational numbers. So some of this is review. No matter what you took last year, you had a topic that you discussed of whether numbers were rational or irrational. So some might have gone in more depth than others, depending again if you took course 2 or course 2 advanced. However, everyone learned what a rational number is. This topic is going to involve operations with rational and irrational. So think about what operations are: adding, subtracting, multiplying, and dividing. So before we can get into that, we need to go back and understand our number system. So notice there's 2 types of numbers in our number system. You have imaginary numbers, and we write that with an I, and it's kind of like a little cursive I like this. Now, we're not going to get into that this year. You are going to get into it. There's a whole unit on it in Algebra 2. But understand throughout this school year, when we're doing things, I might say to you, oh, well, not yet, but there is a possibility, or that would be an imaginary number. So there is a number that exists that's imaginary, and we use that I to represent it. What we're going to deal with, what we've been dealing with, our whole math career, per se, are real numbers. So what are real numbers? Well, a real number is just any value that represents a quantity. So anything that represents something. A real number can be represented as distance on a number line. So all these fall in the real number realm. Now, within the real number system, you have rational or irrational numbers. So we start with our very basic type of number, and that's a natural number. Those are numbers that we have always used for counting and ordering. When you were in preschool, you started with natural numbers. Most of you didn't start with 0. You started with 1, 2, 3, 4, and you counted and you sorted things. Those are natural numbers. Then we introduced you to 0. So a whole number basically is all positive numbers, okay, including 0, without decimals or fraction points. So would natural numbers be a whole number? They would. That's why you have that circle within the whole number circle. Because if it's in the natural, it's in the whole numbers. Next, I would say, again, some of you may be 6th grade, some of you may be in 5th. We introduce integers. Integers are all whole numbers and their opposites. So 5, -8, 12, okay? They have a positive and a negative. Now, rational and irrational, that's what this whole topic's about. So let's go to that and see what those are. What are rational numbers? Well, simply put, it's anything that can be written as a fraction. The definition is any number that can be expressed as a ratio of 2 integers. So a lot of people get confused by that. What I need you to understand, a rational number, you can write it as a fraction. Okay? Simply put. So if it's a fraction, if it's already a fraction, it's rational. Integers, those are rational numbers. Doesn't matter what the integer is. Okay, this is important to understand. Terminating decimals, meaning a decimal that ends. Because I can turn that into a fraction. Like the 0.36, I can put that over 100. I will put in the comments, in the description of this video, another video on how to convert decimals to fractions and fractions to decimals so that you can have a refresher on that. A perfect root. Notice I didn't say perfect square. A perfect root, because you might see a cube root. You might see a 4th root. So anything that has a perfect root to it, that you can do it without a calculator. Now, repeating decimals. Repeating decimals can be made into a fraction. Instead of putting them over 10, 100, 1,000, like we do with our terminating, we put them over 9 or 99 or 999. That's also in that video in the description below. So make sure you check that out if you're a little confused. Now, you'll hear me say irrational. And I emphasize the E, even though there's no E there. I think because a lot of people, when teachers are talking, they say irrational, irrational. And you don't hear the difference between the two words. So I emphasize it a little bit more. But what are irrational numbers? Simply put, it's a number that cannot be written as a fraction. Okay, well, what do those look like? Non-terminating, non-repeating decimal. The most famous one is pi. So I'm going to give you advice. If you see anything that has pi in it, I don't care how many pi's there are, it's irrational. There's nothing there. Now, look at this decimal. See how it says 0.2478395,723 ... Notice nothing, it's not repeating. That ... means it's also not terminating, that it's going on forever. So these two would be irrational numbers. But you also have non-perfect square roots, or roots, I should say, not just square roots, non-perfect. Okay, you're pretty much only going to see the square roots this year. Meaning I can't find that square root without getting out a calculator, or I'd have to approximate it to the nearest decimal. There's also a video in the description for that if you'd like to see that one. So let's go through and think about this. Let's look at the first one, 3 1/2. Now it's a mixed number. It's not a fraction, but I have the ability to rewrite it as a fraction, as an improper fraction. Therefore, it is rational. The square root of 5, that's not a perfect root. Therefore, it is irrational. Then notice what I have here. These ... at the end. You have to understand that. Some of you are used to seeing the bar over our decimal to mean repeating. The 3 dots at the end also mean repeating. And if you look at or going on, I should say, this is repeating. It's all 3s. So it's rational. Then 4.75. It's a decimal. It's rational. And right away, you should have already marked off the last row. That's pi. It's irrational. Okay? So right now, I want you to determine if each number is rational or irrational. Okay, let's go take a look. I have the square root of 122. That is not a perfect root, so it is irrational. Then I have 3/10. That's a fraction right there. It's rational. Done. And here I have a negative decimal. That's okay. I can still make it a fraction. It's rational. So now that we've gone through the difference between the two, that's going to take us to this concept. This concept wants us to understand that if I add a rational and irrational, what will I always get? So this question says, select all the following that result in a rational number. You've got to go one at a time, okay? So if I look at the first two, or the first one, I should say, the square root of 49 is 7. The square root of 16 is 4. 7 minus 4 is 3. 3 is a rational number. Therefore, that one results in a rational number. Now, look at this. Are any of them rational? No. So if I add or subtract all irrational, guess what? I'm going to get irrational. Okay? I can't add radicals whose radicands are different. So I have a radical result here. So I don't put an X in it. Now be careful on this one. A lot of people would say, oh, pi, it's irrational, move on. But you got to look. Because you have 10 pi minus pi times the square root of 100. Well, what's the square root of 100? 10. So really you have 10 pi minus 10 pi, which is 0. Therefore, it's rational. So you have to slow down. You can't just look at one thing. You actually have to first simplify the expression and see if it works. Okay, now this one's a little complex. There's a pi there. And yes, I said anything that has a pi in it is irrational. But you're going to have to go do the box method because we need to make sure that nothing cancels out. So I'm going to put pi, and then I'm going to put negative square root of 3. Pi square root of 3. When I start multiplying, okay, remember I'm just multiplying the top and the side. This is what I put in there. When I bring it out, pi times pi is pi squared. Pi times square root of 3, square root of 3 pi. Sorry, that pi should be on the outside, not on the inside. And then I have square root of 3 pi. Then I have square root of 9. So that leaves me with pi squared. Well, these two are going to cancel. Remember that pi on the yellow one should be outside. That was just a typo. Well, they're gone. So it just leaves me the square root of 9. Well, can I take the square root of 9? Yeah, it's 3. So that expression is pi squared minus 3. Well, let's go back. That's an irrational number. Okay, so we're not going to put an X. Let's go to the next one. I have a irrational minus a rational. Would I be able to figure this out? No, I don't know the square root 11. Okay, if you want to, take out your calculator right now. Type in the square root 11 minus 4. You're going to see the number that appears there is irrational. So if you were asked subtracting irrational and rational, your result is irrational. Now you see why I emphasize the E, because this is a tongue twister when you say the two. Then you have pi squared plus 5. That also results in an irrational number. So finally, we're down here, R plus S. And they say where R and S are both irrational. Well, go back up to the second one. Didn't I add two irrationals and result in an irrational? When you have something like this, pick any two numbers that are irrational. Square root of 3, square root of 8. And try and add them. What do you get? Then pick another two. And this is how you can test these, okay? So yeah, we only picked 2 here. And that's one thing that I want you guys to start understanding. On these multi-selects, sometimes you only pick 2. You will for fact pick more than 1. How many is going to depend. So after going through this, let's take a look. This is where I say, test it, pick something. What I want you to decide is it always, sometimes, or never true? If I add the sum, so if you don't know that the sum means to add, please write that down in your notes right now. The sum of a rational number and a rational number is rational. Is that true? Sometimes, always, or never. Pause now and try these on your own. Okay, so I read you that first one. So now you understand what we're doing. You're saying, is that always, sometimes, or never true? This one is always true. If I add a rational plus a rational, I'm going to get another rational. But if I have a rational number and an irrational number, it will result in an irrational number. That's also always true, because if one of them is irrational, no matter what you add to it, its answer is going to be irrational. Okay? The product, if you don't know, please write it down now. The product of means to multiply. So that means I'm multiplying these. I'm multiplying a rational number and a rational number. and they're saying I'm going to get irrational. That's right. It's always. So don't think you can't have 3 always in a row. Okay? That's the other thing. You have to know your facts. Then we're going to go to the product of a rational number and an irrational is irrational. So you're going to do a rational times an irrational. Remember what I said on the last one, the last problem before all these. Pick 2 numbers. Okay, so a rational number is 2. 2 times the square root of 5. Is it irrational? Sometimes. Because you could get the square root of, let me think. You could pick a perfect square times not a perfect square, but get a perfect square. So that's why this one is sometimes. So when I said, okay, 2 times square root of 5, that one didn't work. But you have to think of some others, and that's what I said prior. You got to plug in other values and see what might work. Last, you have the product of an irrational number and an irrational number is irrational. So you're multiplying, okay? So square root of 5 times square root of 5. What does that give you? That actually gives you 5. So are you always going to get an irrational number? No, you'll sometimes get one, okay? So I'm not saying this is going to be a walk in the park, but test it. Plug something in. You're going to have to pick more than one thing though, okay? So some of you might understand it because it's understanding what is irrational, what is rational. You might want to go back and rewatch the videos that are in the description or go back and rewatch this video. If you have to watch it and you get it before you come to class, hit like. I want to know how many are coming in understanding. You know, I go in and I look at it before class starts. Or make a comment. What don't you understand? Was it the sometimes, always, or never? Was it identifying if the expression was rational, irrational? Let me know and then summarize. Keep this in your notes. Remember, I read them when you submit them.